It looks like the majority of you are waiting to the last day or two before the due dates on these Chapter 7. Doesn't bother me, though I did give everyone a month head start. But these are due Monday. This is Saturday. So I thought I'd help you out, those of you who haven't done these yet. So practice problems seems to be what takes up the most time. And so, again, I'm not going to do this every week, but I know some of you are having trouble, so let's go ahead and do this. So here's what I see when I go in there. Madison Motors bonds have 10 years remaining to maturity. Interest is paid annually. They have 1,000 par value. Coupon rate is 9.5%. Yield to maturity is 11%. What's the bond's current market price? Now here, I would use my financial calculator. There's 5 time value buttons across the third row of it. N, I, PV, PMT, and FV. If you enter 4 of those parameters, if you input 4 of those and solve, you would be able to solve for the 5th one. Here, 10 years remaining and interest paid annually. So the coupons, there's going to be 10 coupon payments, and the maturity payment is also 10 years out. So N on my calculator is 10. So I would type 10 and then press the N button. And then it says the yield to maturity. I'm going across the row, and I is next. So yield to maturity is what I would put in for the interest rate, and that is 11%. So I'm putting 11. Again, that's annual already. Put in 11 for interest rate. The coupon payment is, it says, coupon rate is 9.5%, 9.5% per year of $1,000 par value is $95. So I'm putting in 95, and I type 95, then press the PMT button. And of course, 1,000 is FV, future value. And then I press compute, CPT, and the PV button. And I'm getting 911.66. Let's go ahead and check that. You guys remember to save your work as you go, just in case, so you don't have to go and redo stuff. Next question. This bond, $1,000 par value, 15 years maturity, annual coupon. So N is 15 again. Put in 15 for N. I'm sorry, N is with annual. When the coupons are annual, N is the number of years to maturity. If the coupons are semi-annual, then N would be twice per year, so 2 times the years to maturity. And the coupon rate is 8%. If it were semi-annual, I'd divide by 2, but here again it's not. So I just take 8% of the par value, which is $80. So I put in 80 for PMT. Okay, what are we looking for here? It sells for 1,080, so I'm going to put in 1,080 for present value. I'm going to make it negative because, well, there's 3 kind of inputs that would have dollar signs in front of them, PV, PMT, and FV. One of those needs to be negative. On my calculator, I'm using a Texas Instrument BA2+, as it says in the syllabus. One of those has to be negative in order for the interest rate to make any sense whatsoever. I mean, think about it. If you're receiving money today and in the future, what's your rate of return? It's not, it's infinite, so, or undefined. So you have to pay to receive something. We're paying the price. So 1,080 with a negative sign in front of it would be PV. So here we solve for the yield to maturity. So we're computing I, CPT, and then I. I'm getting 7.115 and 7.12 rounded off to the nearest 2 decimal places. And just to check there. And if the yield to maturity is the same 3 years later, what would the price be 3 years later? Well, there we're just going to take 3 years off of 15. So change N to 12, type 12 for the price, and we get, sorry, change N to 12 and compute the price. We get 1,069 1069.84. Okay, number 3. And number 3, bonds have 1,000 par value, 6% semi-annual coupon, 11 years maturity, 7% yield to maturity. What's the bond's price? So here again, 1,000 is the future value, or FV on our calculator. But PMT, where it would be 60, that's 60 per year. 6% of 1,000 is 60, but they're semi-annual payments, so we divide that by 2 to get 30. So you put in 30 for PMT, not 60. 11 years to maturity, but there are 2 coupon payments per year, so we multiply that by 2. That is, there are 22 annuity. There's like a 22 period annuity of $30 per 6 months. So put in 22 for N, and 7% yield to maturity. That's per year, and we want the interest rate per coupon payment period, which is 6 months. So we divide that by 2. So put 3.5 for the interest rate, and solve for PV, and we get 924.16. Next question. Okay, here, yield maturity, maturity is 8 years, 1,000 par value, 11% semi-annual coupon. Okay, so let's break this down. That's 8 years with 2 payments per year, is N is 16, so put in 16 for N. The coupon rate is 11% semi-annually, so that's 5.5% per 6 months, so put in 55 for the PMT. It's callable in 4 years. Currently sells at a price of 1267.25. I'm going to go ahead and put 1267.25. Make it negative because you have to pay that negative cash flow for present value. All right, so first we're solving for the nominal yield to maturity. Given what I've just entered in my calculator, I can just click. I've entered N, PV, PMT, and FV. FV is 1,000. Solve for the interest rate I, and I get 3.32. Now that's going to be per payment period. That's per coupon payment period, which is semi-annual. But as you know, interest rates are always reported in a per annum basis, so I need to multiply that by 2. So once I've computed I say times 2, and then I get 6.64, of course. So 6.64, whoops, not 54, 64 would be the yield to maturity. Now it's asking for the yield to call. Now here, this is what the yield will be if it is called. And if it's called, then you'll get not 1267, but 1146. So you'd put in you'd get 11. If it's called, you would get $1,146 instead of the principal payment of $1,000. So we have to change future value from 1,000 to 1146. So type 1146, then press the FV button. And it's callable in 4 years. That's 8 periods. That's 8 payment periods. So N would be 8. That's basically when we find the yield to call, we're finding what the yield to maturity would be if it were called. And the call price, we would substitute for the face value. So N is 8, which is 4 years, twice per year. And that's basically all we need to do. We just now solve for the interest rate. Keeping in mind, again, we already have PMT. That's already in there. Keep in mind, again, this is per payment period, so that's per 6 months. We need to multiply that by 2, times 2, to get the per annum, per year, yield to call, which is going to be 6.5491, or 6.55 rounded off. Okay, what return should investors expect to earn on these bonds? Well, given that there's a 50% chance of market rates going up or down, that is yields going up or down, the coupon rate's not going to change. That's written into the contract. So if there's a 50-50 chance of it going up or down, we would expect it to pretty much stay the same, in which case it's more likely that the company would choose to pay the lower of those two rates. That is the 6.55, since it is less than 6.64. So it's most likely going to be called, or it's more likely than not anyway, to be called 4 years from now, in which case bondholders would get 6.55%. So uh, you should expect the bonds to be called because it is less, not greater. So one is wrong because uh, it would you would not earn the yield to maturity if it's called. So 2 and 3 are wrong because number 4 is correct. Expected the yield to call is less than the yield to maturity, therefore it should be called. So let's go ahead and choose number 4 and move on. Next question. Oops. Sorry, it's number 5. Okay. Number 5. Okay, here we have 2 bonds in the portfolio, have a face value of 1,000, pay 6% annual coupon. Bond L matures in 20 years, while bond S matures in 1 year. So they both have the same coupon, but one has a much shorter maturity than the other. Otherwise, they're basically the same. Only one more interest payment is to be made on the bond S. Well, and that 20 more payments on bond L. What would be the value of bond L if the going interest rate is 6%? Well, for L, we would have 1,000 future value. Its face value is 1,000. 6% coupon per year, that's 60, or 0.06 times 1,000. There's 20 payments, so put in 20 for N. And the going interest rate would be the yield to maturity of 6%. So you put in 6 for the interest rate and compute PV. And just to double check, these are annual coupons, not semi-annual. When I do that, I get 1,000, which shouldn't surprise anybody because the market interest rate, 6%, is equal to the coupon rate, which means that each annual coupon is just paying 6% of the face value, or basically the interest portion. So it's like they're paying the interest every year for 20 years and then paying off their loan at the 20th year. So anyway, the answer over here is going to be 1,000. Anytime the coupon rate equals the yield to maturity, the bond will sell for its par value. And on the origination date, that is when they draw up the papers, they do try to set the coupon equal to market rate so that it sells as close to par as they can get. Normally, not always, but normally. Okay, what's the value of the bond S if the interest rate is 6%? Well, there again, with bond S, it's paying a 6% coupon. It says that both bonds are paying 6%, so that should also sell for 1,000. I don't really even need to make the calculation. If the interest rate is 9%, what's bond L? Well, there I can just change N to, I to 9 and recompute present value. And just as a common sense check, if the interest rate is 9% and the coupon rate is 6%, that means the coupon, $60, is less than the interest that's being charged. And so you should expect this bond to be selling for less than its par value. It is a discount bond. And when we do solve for present value, we end up with 726.14. Rounded off. And now for S, here just change N to 1 and recompute present value. The rest of those variables should still be in there. 972.48 rounded up, 477, so 48 rounded up to the nearest penny. And that also makes intuitive sense. The 20-year bond is paying less than necessary to meet the required rate of return or market interest rate for 20 whole years, whereas bond S is just making one coupon payment, which is less than the market rate of interest. So it's not going to be discounted by as much. What would be the value of the bond if the interest rate is 11%? So now it's going up by more. We expect them both to decrease in price. However, the bond that is long-term will decrease in price by more. So again, we put in 11 for the interest rate. I'm going to go ahead and compute the one-year bond first, which is S 954.954. Yeah. And then I'm going to change n back to 20 and recompute present value, and I'm getting 601.833. Okay, so they both went down, but the long-term bond went down by a lot more, both in percentage terms and dollar terms. Why does the long-term bonds vary more? As I just well, let's see what how they put it. They have lower reinvestment rate? No, they have the same reinvestment rate. The change in price due to a change in the required rate of return increases as the bond's maturity decreases. No, it's kind of backward, isn't it? Long-term bonds have greater interest rate risk than do short. That's true. So 3, let's just look at the other two just in case. The change in price due to change in required rate of return decreases as the bond's maturity increases. No. Again, that's backwards. Long-term bonds have lower interest rate than short. No, not necessarily, and not in this case anyway. So the answer there is 3. Long-term bonds have greater interest rate risk than do short-term bonds, which just means they're more sensitive to a given change. And if both yields are changing by the same amount, the long-term bond will change in value by more. So let's go ahead and check those. And they're correct. So yeah, on to number 6. Here we have 2 bonds in the portfolio, C and Z. Each bond matures in 4 years. They both have face value of 1,000, yield to maturity of 8.9%. C pays 11.5 and Z pays 0. So here we would expect Z to be more sensitive to changes in interest rates. Okay, assuming the yield to maturity stays at 8.9 over the next 4 years, calculate the price of the bond at each of the following years to maturity. Okay, so at 4 years to maturity, here we're going to put, actually I'm just going to go down one column at a time. So first we'll go with the coupon bond. So again, face value is 1,000 as it is in all of these cases. The years to maturity for both bonds is, well, it starts out at 4, so let's put n equals 4 and 8.9, the interest, the yield to maturity rather, 8.9 for I over Y. And let's go ahead and put the coupon in. So C pays 11.5 annual, so that's $115. That's 11.5 of 1,000, and I'm going to compute present value. And this is a common sense check. The coupon rate 11.5 is higher than the yield of 8.9, so we would expect it to sell for more than its par value. So that's 1,084.417, so 42. Now, for expediency, I'm going to just change n to 3. I'm going to go down the column instead of going across the row. So change n to 3, press 3, then n, and then recompute present value. And now I'm getting 1065.931, so 93 rounded off. And that's as you would expect, since it's a premium bond in this case, we would expect its price to decrease as we get closer to the maturity date. Next line, we're going to change n to 2, change n to 2, and then recompute present value. It literally takes 2 seconds to do that. So 1045.799, which is 80 rounded off. Now just changing n to 1 and recomputing present value, we get 1023.875, so 0.88. And then at its maturity date, it should be, well, I think the answer is 1,000, but we're assuming that it's just paid the final coupon and hasn't paid the principal yet. Now for bond Z, we just go back. Actually, we may as well start. Yeah, that was fine. Just change PMT to 0, press 0 and the PMT button, and we'll just go through the same routine. Change N to 4 and compute present value on our calculators, and we get 711.03. So 711. Now change N to 3, press 3, then N, then press compute PV. We get, whoops, what did I do? Yeah, and here it's a deep discount bond, and so that is selling less for its par value. So as we get closer to the maturity date, we would expect the price to go up, so that on this maturity date it equals its maturity value. Here I get, when I change N to 3, 774.312.31. Now change N to 2, recompute present value, I get 843. Changing N to 1, recomputing, 918.273. And finally, honest maturity date, it only has the, there's no discount left, so it's worth its par value. It's worth the principal payment. The correct graph, you can see that bond C is decreasing down to 1,000 and bond Z is increasing. So actually that first one is correct. Actually, no, it's not correct because they're both equal to 1,000 on the maturity date. So it'd be C. Let's go ahead and check this. All right. And next we have number 7. Five bonds. Each bond has a par value of 1,000, 8% yield. And just after you buy them, the interest rates fall. So to 5%. And what they want to know what the percentage change. So here we have to recalculate the price of each of these things at 8% and then at 5%. So again, put 1,000 in for FV, face value, or future value. Okay. And we have a 10%, 10-year, 10% annual coupon. So if it's 10% annual coupon, that means 0.1 times 1,000 is 100 for PMT, the coupon payment. And N is 10, so put in 10 for N. And both it says have an 8% yield to maturity, so I'm putting 8 in for I over Y and computing present value. And I will get 1134.420. Now to get the price at 5%, all I need to do is change I to 5. Press 5, then I over Y, and the CPT button and PV. I'm getting 1386. 0.086, so 0.09 rounded off. Percentage change would be the, well, second column over the first column minus 1, or second column minus first column divided by first column. Either way you want to do it. So we would take that number and divide by 1134.42, subtract 1, and I'm getting 22%. It's increased by 22%, or 22.184. Close enough. For 10-year 0, here we just change payment to 0. Okay, and recompute. 5% is in there right now, so recomputing present value would give us the 5% yielding 0 at 613.91. And then now we just change the interest rate to 8%, press 8, and then I over Y, recompute present value, and we get 463.193. 19 rounded off. Now just, again, common sense check. Which one would you expect to cost more? The one that has a yield of 5%, or that 10-year 0 coupon bond, that is. This is, we're discounting a single lump sum payment of $1,000 occurring 10 years out. Now if we're discounting at 8%, you expect that to be more or less than discounting the same amount at 5%. It'd be less than, right? Because we're discounting at a higher rate of return or with a higher discount rate. Just think about the present value equation. Present value equals future value over 1 plus I, the interest rate, to the nth power, where n is 10 in this case. All right, so that makes sense. The higher discount rate means we're discounting it more per year. So we have a lower present value. Now let's change n to 5 and recompute present value, and we get, this is at the 8% if I recall, we're getting 680. We didn't change it. We didn't change I, it's still 8%. We just changed n from 10 to 5, and now we're getting 680, 0.583, so 0.58 rounded off. And now just change interest rate from 8 to 5, so press 5 and then I over y and recompute present value. And you get 783.526 or 0.53 rounded off. Again, the change is second column divided by first column minus 1, so we take that number and divide by 680.58, subtract 1, we're getting 15%, 15.126. Whoops, sorry. 15.126, and I see that I didn't do it for this one. So again, this would be a second column minus first column. 613.91 divided by 46319. 3254. Okay, so with the longer time maturity, you have a much greater change in the price percentage-wise. For a 30-year zero, what do you think is going to happen? Well, here again, we're going to just change n to 30 and recompute present value. And that was at 5%, right? So, yeah. So that gives us 231.377, so 0.38. And change the interest rate to 8. Press 8 and then I over y, recompute present value, and we get 99.38. So first over second, yeah, so 231.38 over 99.38 minus 1 gives us 1.32. So that's like 132%. 0.823, so 0.82. What a large change that is. So we can see with the zero coupon bonds, the longer the time to maturity, the bigger the change in price, and is pronounced. Now the perpetuity is the perpetual payment divided by the interest rate is how you'd find the present value. So here the perpetual payment at 8%, that's I'm sorry, $100 on perpetuity, it says. So that'd be 100 divided by 0.08. So 100 divided by 0.08 gives us 1250 even. And then the 100 divided by 0.05 would give us 2000. Percentage change is 2000 over 1250 minus 1, which is 60%. Increased by 60. Let's go ahead and check these. I'm going to go ahead and take a break here because well, the rendering of this video is going to take a long time.